For this first example, we're trying to prove that triangle DXC, shown here DXC, is congruent to triangle BXA. So what we're going to do is something called the two-column proof, and what that basically means is we're going to make a series of statements down the left-hand side, and then in the second column on the right-hand side, we're going to justify our answers. We're going to give the reason for the statement on the left. So the first statement that I'm going to make is one of the given statements, and generally when you do a given statement, you just write given as the justification. So my first statement will be X is the midpoint, I'm going to abbreviate a little bit, of BD. And I'm going to state that that is given. Well, if X is the midpoint of BD, what I then know is that XD is the same length as BX, and that would be my next statement. So I'm going to say DX is congruent to BX. And this is because we have the fact that X is the midpoint. So I'm just going to say that the justification for that is the definition of a midpoint. The next thing I'm going to do is actually work with my second given statement. And the second given statement is that X is the midpoint of AC. So if X is the midpoint of this diagonal, then I know that AX is congruent to CX. And that would be my statement next, my next statement. So for 3, I'm going to say X is the midpoint of AC, and that was given. So that should go straight across. I could almost number it 1, 1, 2, 2, 3, 3. So then I'm going to use the same logic that if it's the midpoint, then these two sides are the same. So for 4, I'm going to say that XC is congruent to XA, and that is also the definition of a midpoint. Okay, never lose sight of the goal. The goal I have here is that I'm trying to prove that triangle DXC is congruent to triangle BXA. And what I actually have right now is I have two sets of congruent sides. So one of the nice ways to do it would be if I knew for some reason that DC was the same thing as BA or something like that, but I don't have that. But what I do have are a couple of vertical angles, and what you're looking for are sides that match or angles that match. So I know that this angle here is the same as that angle there because they are both vertical angles. So I'm going to say for statement 5, angle DXC is congruent to angle BXA. And the reason is because they are vertical angles. So if you look at what I have now, I have that DX is the same as BX. The included angle DXC is the same as BXA, and then I have that XC is congruent to XA. So I have a side, an included angle, and another side congruent to the side, included angle on the other side. So by side, angle, side, my triangles are congruent. So that would be my last step. So triangle DXC is congruent to triangle BXA. And the reason for that would be side, angle, side postulate. You really just want to make sure you start with the given and end. You have to end with what you're trying to prove, and then you're done.